Hello, this is the Disaster Recovery Pro, and this is my video series discussing key topics in information technology with a focus on disaster recovery and business continuity. Today's presentation will be part 3 in our series about the evolution of disaster recovery. Here we'll take a look at the impact of virtualization on disaster recovery best practices. While some of this impact is not immediately obvious, it really was a game changer that laid the foundations for the next set of big developments. Virtualization changed the game for IT in general, not just disaster recovery. It allows you to abstract away the physical hardware running your workloads, which means that in disaster recovery, you don't have to worry about hardware compatibility issues. What used to be a physical server is now a VM, or a virtual machine, that is treated as a complete object rather than a collection of files, settings, and hardware components that all have to be handled individually. An entire VM can be backed up and restored or replicated as one complete object, which greatly streamlines the recovery process. Many modern databases and applications are built to be virtualization aware, so the recovery is less traumatic to their operations, no more so than a clean reboot of the system would be. Most modern database engines will automatically start from a last known good state that ensures that your data is crash consistent and minimizes data loss in an event. The option to recover individual files can still be preserved in most cases, but it's usually not necessary in the case of a full recovery. Just about every hypervisor, that's the software engine that allows virtualization to happen, will support some degree of failover capability, which allows for greater operational resiliency than before, so you can fail over your operations rather than have to recover them. Overall, virtualization gives you capabilities that simplify and streamline the process of recovery, and it gives opportunities to have a highly available state rather than just a recoverable state. Most virtualization methods follow a similar multi-level model like the one shown here. You will usually have a management layer that's a physical or virtual host, sometimes even a virtual appliance, that acts as a global management console to manage your entire virtualized environment. This management console will allow you to perform actions such as managing the base hardware, storage, and networking, create, change, and manage virtual machines, and monitoring and logging of events. Next, we have the hardware layer. This is the collection of physical servers you will be running your VMs on. It not only includes the CPU and memory resources, but also includes the physical networking and any internal or external storage involved as well. The hypervisor is the software component that runs on top of the physical hardware. The hypervisor has control of all the collected hardware resources and allows you to treat them as a pool of compute, storage, and network resources that can be assigned out to our virtual machines. At the virtual host layer, you have the VMs that you define. Each VM is assigned hardware resources and acts as if it were a physical server. Each VM is allocated shares of the available CPU and memory resources, access to the underlying network, and a section of the available storage to use as its own. This is somewhat of a simplification, but VMs essentially are a set of resources granted by the hypervisor that are logically separated from each other. This abstraction of the underlying hardware opens up many ways to manage resources that are not possible when using individual physical servers. When one VM is idle or at low capacity, the excess resources assigned to it can be used by VMs that are running at high utilization. This allows your collection of physical hardware to run more virtual machines than you would if you just ran physical servers on the same hardware, and it makes better use of resources, compute power, that would otherwise be sitting idle, waiting for short periods of high usage, can be used for other processing. A virtualized server farm can easily scale. VMs can easily be added on the fly without purchasing new hardware as long as there is enough capacity. When you run short on capacity, you can add additional physical hardware. You can just purchase hardware and add it to the environment with little to no impact to running workloads in most situations. Because a VM can be treated as a single object, backup and recovery is greatly simplified. Just about all modern backup software will allow you to back up a VM as a complete unit rather than just backing up the collection of files and other data that's inside the VM. When you recover a VM, you have the option of restoring all the component files and piecing the VM back into a working host, just as if it was a physical server, or you can simply restore the entire VM as a single unit onto the recovery environment and simply start up the VM as if it went through a reboot. We can move this data into the recovery environment by any of the methods that we would use for a physical server recovery from backup, by shipping the backup tapes to the recovery site, or by replicating the backups themselves over to a backup server in the recovery environment. In either case, the concept is the same as what we've seen before. To ensure that the VM is crash consistent, meaning that the data within a VM is consistent enough that the server can restart after a restore with minimal impact, most virtualization engines will allow you to create a snapshot of each individual VM, which is basically a near-instant, point-in-time copy of the entire VM that is idle. This snapshot, since it is not a live host that may be processing transactions or have unresolved data writes waiting to happen, can be backed up in place of the live running VM and be in a consistent state. This is very similar to the block volume level snapshots that we would see on a storage array. The process of restoring the VM is reduced to a single operation with minimal follow-on actions to render the restored VM operable. In many cases, the post-restore actions can be as simple as turning the restored VM on. And in cases where post-restore actions are needed, the typical actions are very straightforward adjustments to things like network settings, or pointing the VM at a different DNS resolver or domain controller if the recovery environment is significantly different than the production environment's network landscape. In most virtualization engines, you also have the option of using storage replication in place of the backup restore method in order to achieve shorter recovery times. If all of the storage used by your VM farm is on a disk array that can be replicated to the recovery site, you can present a snapshot of your replicated storage volumes that contain your target VMs to the physical hosts that make up your virtualized environment. Once that storage is presented, it can, in most commercial virtualization engines, be imported into the environment through the management console, and the VMs it contains can be added to inventory and started as if they were just restored, with minimal, if any, adjustments post-import. This is a large advantage over the backup restore approach, since you are effectively restoring all of your protected VMs at once, which allows focus to be on starting up the VMs in a reasonable order, making your minor post-restore adjustments, and addressing issues that have come up, rather than managing a large number of VM restore operations before you get to these things. Many modern hypervisors have native or add-on capabilities that can either manage or even perform storage replication for you, and in some cases even execute post-startup actions and manage VM startups in an automated fashion. They can even manage the shutdown of corresponding VMs in production and transform your recovery through replicated storage into a more turnkey managed failover and failback operation. Let's summarize the key advantages that virtualization brings to disaster recovery. The primary advantage is the ability to treat a VM as a complete object rather than a collection of objects. Instead of backing up and restoring all the things that make up your specific server, you can back up and restore the entire VM as a single unit. And this is the basis for all the other advantages that we gain. Virtualization opens up more options for automation, and in some cases includes native tools that can automate some or all of your recovery on its own. When you simplify the recovery process, you allow your disaster recovery team to spend more of their time dealing with problems and worrying about ensuring that their applications come up and are usable, rather than spending the bulk of their time managing restores. As more and more developers start building their applications with virtualization in mind, application startup after a recovery tends to become a matter of simply restarting your VMs in a logical, predetermined order with minimal issues to work around, rather than having to log in and perform all these administrative tasks to bring your application back online. All of this allows your environment to achieve shorter recovery time objectives and allows you to achieve a more turnkey approach that moves you towards operational resilience, which is resistance to outages with minimal or no downtime, as opposed to a recoverable stance, where you expect to have a significant period of outage before your business can resume. The use of virtualization sets the stage for the next big movement in disaster recovery, recovery as a service, also known as RaaS. Virtualization opened the door for service providers to build automation around recovery that allows them to package it as a turnkey managed service that provides a high degree of self-service functionality. And when we return in part 4 of this series, we'll explore this in more detail. Thanks for watching today's presentation. If you found this topic interesting and you want to learn more about disaster recovery and business continuity, you can help support the channel by leaving a comment to tell me what you thought about it, clicking like on the video, and most importantly, subscribe to the channel and click the notification bell so that you won't miss out on my next video. Your support and feedback is very important, so thank you for watching and supporting the channel, and have a great day.